Our user interface for this game is going to be fairly complicated, but we can assemble it piece by piece and have auto layout do most of the work for us. The main part of the UI will be two large labels, one containing the clues the user has to figure out, and one showing how many letters are in the word for each clue. So it might say, a cow in a tornado in one label, and 9 letters in the other, with the answer being milkshake. As the player solves each clue, the letter count will be replaced with that answer so they can see at a glance which ones they've solved. Just above and to the right of those two labels will be one extra label, nice and small, which will show the user's score. In the middle of the screen, we'll have a UI text field where we'll store the user's current answer, plus buttons below to submit the answer or clear it. Finally, at the bottom we're going to make 20, yes, 20 buttons, each containing different parts of the clues. So there'll be one with MIL, one with KSH, and one with AKE. The user needs to tap all 3 to spell milkshake. To make our layout a little easier, we're going to place those buttons inside another UI view that we can position centered on the screen. Now our game is designed for iPads, so we've got a lot of information we want to cram in. Later on, you're welcome to try and create a second layout specifically for iPhones, and it is possible, it just takes a lot more thinking. The first thing we're going to try and do is create 5 properties to store the important parts of our UI. The clues label, the answers label, the player's current answer, the word they're spelling, their score, and all the buttons showing word pieces. So let's open viewcontroller.swift. I'm going to add 5 properties to the viewcontroller class. We'll say var clues label is a UI label, implicitly unwrapped. Var answers label is a UI label, implicitly unwrapped. Var current answer is a UI text field, implicitly unwrapped. Var score label is a UI label, implicitly unwrapped. And var letter buttons is a UI button array, like that. Just like in projects 4 and 7, we're going to write a custom load view method that creates our user interface in code. This is going to involve much more work than just making a WK web view though. We have lots of UI to create. So we'll tackle it piece by piece so you can see it coming together as we go. Let's start nice and easy. Make load view. Boom. We're going to create the main view inside there as a big and white empty space. This is just a matter of creating a new instance of UI view, giving it a white background color and assigning that to our view controller's view property. So let's say here, view equals UI view, view.background color equals .white, and there's going to be more code to come there. Now UI view, this thing here, that's the parent class of all of UIKit's view types. That's labels, it's buttons, progress views, and more. Now previously we assigned a WK Web View instance directly as our view, meaning they took up all the space of our view controller automatically. Here though, we're going to be adding lots of child views and positioning them by hand. So we need this big empty canvas to work with. That's our UI view. Next, let's create and add the score label. This uses similar code to what you learned in Project 6, although now we're going to set the label's text alignment property so the text is right aligned. So I'll replace this more code to come comment with score label equals a UI label. Then score label dot tamic, which stands for again translates auto-resizing masks into constraints, equals false. We'll make constraints by hand. Score label dot text alignment equals dot right, so it's right aligned text. Score label dot text is score 0, and then view dot add subview that score label. So this code here creates our score label. We need to add some auto layout constraints to make that label be positioned neatly on the screen, and we're going to be using anchors just like we tried in Project 6. These let us clearly and descriptively place views relative to each other. However, this time I want to show you one important difference. Because we're making lots of constraints at the same time here for all our views, we'll be activating them all at once rather than setting isActive equals true multiple times. This is done using the NSLayoutConstraint.activate method, which accepts an array of constraints. It'll put them all together at once, so we'll be adding more constraints to this call over time. UIKit gives us several guides we can anchor our views to. One of the most common is the Safe Area Layout guide of our main view, which is a space available once you subtract any rounded corners or notches. Inside that is the Layout Margins guide, which adds some extra margin so the views don't run to the left and right edges of the screen. In this app, we're going to be using the Layout Margins guide, so our views are indented a little on each edge. But we'll also be adding some extra indenting to make the whole thing look better on screen. So, below that previous code, add this. NS layout constraint dot activate. It takes an array of constraints to activate. So we'll say score label dot top anchor dot constraint equal to view dot layout margins guide dot top anchor with no constant attached to it. Then score label dot trailing anchor dot constraint equal to view dot layout margins guide dot trailing anchor, again with no constant attached to it. I'm going to add some more constraints here. Now notice the way I'm pinning this label to view.layoutMarginsGuide. That will make the score label have a little bit of distance from the right edge of the screen. This one here is a top anchor, so it's pinned to the top of the layout margins. This is the trailing anchor, so it's pinned to the right. So the score label will appear in the top right corner of our screen. Now here's an important tip for you. You'll make this mistake a lot and that's okay. This thing here, activate, takes an array of constraints to activate. There's an array inside here, which means every item must have this comma after it. It's an array. Now I'm going to press Command R to build and run the code now. This will launch right now in my iPad Pro 12.9-inch simulator. It's a very, very big device. There are smaller options available to you. For example, you might want to use the iPad 6th generation device instead. You might have many more inside here to choose from. Generally speaking, when you're testing out, you want to use one small device like an iPad and one large device like an iPad Pro. Just toggle between them, see which one looks best for you, and try them both. Your layout should look great on both devices. Okay, so here's our layout in an iPad Pro. Top right there is the score, you can see it right there. I'll try the same thing in the iPad 6th generation simulator, which is a smaller device, so score should look bigger on the screen. Okay, so you can now see score is a little bigger on the screen because the whole screen space is smaller. It's a much smaller iPad device. Now I should say, you might think you'll go for an even smaller device like an iPad mini, and that's okay. But keep in mind the iPad mini has the same screen resolution, the same number of pixels and points on the screen as a regular iPad. It's just smaller in size. So realistically, either choose iPad 6th generation for a nice small device, or the 12.9-inch iPad Pro for a nice large device. Next we're going to add the clues and answers label. This will involve similar code to the score label, except we're going to set two extra properties, the font and number of lines. That font property describes what kind of text font you use to render the label, and is provided as a dedicated type that describes the font face and size, called UI font. Number of lines is an integer that sets how many lines a text can wrap over, but we're going to set it to 0, which is a magic value that means as many lines as it takes to fit the text. So back in our Xcode project again, here we have the code to create a score label. Directly below that, I'll make the UI label for our clues. I'll say clues label equals a new UI label. Clues label dot tamic equals false. From now on, by the way, I'll be saying just tamic for that. You'll get the hang of it, hopefully. Clues label dot font equals UI font dot system font of size 24. Nice big font. Then clues label dot text equals clues. This is placeholder really. And then clues label dot number of lines equals 0. So it'll wrap all its clues across as many lines as it takes. And view dot add subview the clues label. Next is our answers label. We'll say answers label equals a new UI label. Answers label dot tamic equals false. Again, answers label dot font is a UI font, system font of size 24. Answers label dot text equals answers, again as a placeholder. Answers label dot number of lines is 0, and view adds subview answers label. Boom. So the code to create our 2 new labels. Now using UI font dot system font of size is really important. It'll give us a 24-point font in whatever font is currently being used by the iOS system software. This was Helvetica in the early days of iOS. Then it moved to Helvetica Neue, and finally San Francisco. Asking for the system font means we'll get whatever is the standard today, but our UI will update automatically if Apple makes more changes in the future. To position those in such a way they look great on a variety of iPad sizes, from iPad mini up to the 12.9-inch iPad Pro, we're going to set some anchors. The top is the clues and answers label will be pinned to the bottom of the score label, so directly below the score. The clues label will be pinned to the leading edge of the screen, indented by 100 points, so it looks neater. That same clues label will have a width anchor set to 0.6 of the width of our main view, so it takes up 60% of the screen. We need to subtract 100 from this to account for the indent. The answers label will be pinned to the trailing edge of the screen, then also indented by 100 points to match the clues label. That answers label will have a width anchor of 0.4 of the width of the main view, so it takes up the remaining 40% of the screen. Again, that needs to have 100 taken away to account for the indent. Finally, we're going to make the height of the answers label match the height of the clues label. I realize that might sound like a lot of work, but this kind of thing is where auto layout anchors really shine. Just remember, it takes the multiplier into account first, then the constant. So I'll go to our constraints list down here, and let's add some more constraints. Add the comma before the previous one, of course. Then we'll pin the top of the clues label to the bottom of the scores label. We'll say clues label dot top anchor dot constraint equal to score label dot bottom anchor with no constant and a comma afterwards. Next, we'll pin the leading edge of the clues label to the leading edge of our layout margins, adding 100 for some space. Clues label dot leading anchor dot constraint equal to view dot layout margins guide dot leading anchor with a constant value of 100, and that's our margin from the left. Comma afterwards. Clues label dot width anchor dot constraint equal to, and we want this thing to be 60% of the width of our layout margins minus 100 to account for that leading edge margin. We'll say view dot layout margins guide dot width anchor multiplier 0.6 and also a constant value of minus 100. And again, remember the multiplier is taken into account first and then a constant's taken away. So that's our clues label done. Onto our answers label. We also want to pin the top of the answers label to the bottom of the score label. So we'll say answers label dot top anchor dot constraint equal to score label dot bottom anchor with no constant. We'll make that thing stick to the trailing edge of our layout margins, minus 100. We'll say answers label, out with a comma of course, comma here and comma there, answers label dot trailing anchor dot constraint equal to view dot layout margins guide dot trailing anchor constant minus 100. Pull it in from the right edge. This thing has to take up 40% of the available space minus 100. So we'll say answers label, now the comma of course, comma here, answers label dot width anchor dot constraint equal to view dot layout margins guide multiplier 0.4 constant minus 100 comma, and then we'll make this thing match the height of the clues label so they stay the same no matter what. We'll say answers label dot height anchor dot constraint equal to clues label dot height anchor with no multiplier, so it's 1.0 by default. Now I made a mistake here by accident. This should be view layout margins guide dot width anchor, otherwise you'll be confused. Xcode was complaining loudly, which is great. I'll press Command R to build and run the code now, see how this thing looks. And boom, now we have score 0 in top right, plus clues and answers in nice big fonts. Temporarily, just so you can follow along and see how everything works, we're going to add some more code directly after activating our constraints. We're going to say clues label dot background color equals red, and then answers label dot background color is blue. Just give them some temporary background color so we can see these things more clearly, how they look on the screen. I'll press Command R now. And now you can see more clearly that clues takes up most of the space and answers takes up the remainder. Next, we're going to add a UI text field that will show the user's answer as they're building it. You might think this is a good place to use another UI label, particularly because we want players to build words by tapping letter buttons rather than typing into a box. However, this lets me introduce you to the placeholder property of text fields, which draws grey prompt text that the user can type over. It looks really nice and gives us space to provide some instructions to users. As with our labels, we're also going to adjust the font and alignment of the text field. But we're also going to disable user interaction so the user can't type on it. We don't want the iOS keyboard to appear. So when we create these views, we'll say current answer is a new UI text field. Current answer.tamic equals false. Current answer.placeholder, the text to show before the user types anything, is going to be tap letters to guess. Current answer dot text alignment is dot center, and current answer dot font is UI font dot system font of size 44. Like I said, we're going to turn off interaction for user stuff. We'll say current answer dot is user interaction enabled equals false, so they can't activate the text box. And then view.add subview current answer. Boom. The only new part here is this, which is set to false, is user interaction enabled, and that stops users from tapping this box to type something into it. It just acts as an inert label. As for constraints, we're going to make this text field centered in our view, but only 50% of its width. Given how many characters it's going to hold, this is more than enough. We're also going to place it below the clues label with 20 points of spacing so the two don't touch. So I'll scroll down to our constraints array. Here we go. Add a comma before I forget. Beautiful. And then we'll say current answer dot center x anchor dot constraint equal to view dot center x anchor. Center this thing horizontally with no constant. Comma. Current answer dot width anchor dot constraint equal to view dot width anchor multiplier 0.5. So half the width of our screen. Comma. Current answer dot top anchor dot constraint equal to clues label dot bottom anchor with a constant of 20. So put this thing 20 points below the clues label. We'll run it again and see how it looks. Boom. We now see tap letters to guess on there below these two labels. And this thing will not respond to taps. It's not a real text field in that respect. Looking at this thing, I think we'll make one more change to this UI so far. Actually, we have clues here on the left and answers on the left as well. I think I might make answers right aligned instead to make this thing look a bit more symmetrical. So back in our code, we have our answers label here. I'm going to say answers label dot text alignment equals dot right, and see how that looks instead. Much better. Below our text field, we're going to add two buttons. One for the user to submit their answer when they've entered all the letters they want, and one to clear the answer so they can try something else. Now, to create a UI button in code, you have to know two things. First, buttons have various built-in styles, but the ones you'll most commonly use are .custom and .system. We want the default button style here, so we'll use .system. Second, we need to use the setTitle method to adjust the title on the button, just like we did with setImage in Project 2. So back in our view creation code again, down here, sorry, there we go. we'll say let submit equals a new UI button with the type .system. Submit.tamic equals false. Submit.setTitle will be submit for control state.normal, just like with the flag buttons in Project 2. View.addSubView, submit. Then let clear equals another UI button with a type system. Clear.tamic is false. Clear.setTitle is clear for state normal. And then view.addSubView clear. So make out these things as two new buttons we can show on the screen. In case you're wondering, we don't have to store these things as properties on the view controller because we don't need to adjust them later on. They have submit and clear regardless of our game state. In terms of the constraints to add for those buttons, they need 3 each. First, we need a constraint to set their vertical position. For the submit button, we'll be using the bottom of the current answer text field, but for the clear button, we'll be setting its Y anchor so it stays aligned with the Y position of the submit button. This means both buttons will remain aligned even if we move one of them. Second, we're going to center them both horizontally in our main view. To stop them overlapping, we'll subtract 100 from the submit button's X position and add 100 to the clear button's X position. 100 isn't any sort of magical number here. You can experiment with different values and see what looks good to you. And third, we're going to force both buttons to have a height of 44 points. iOS likes to make its buttons really small by default, but at the same time, Apple's human interface guidelines recommend buttons be at least 44 by 44 points, so they can be tapped easily. Alright, let's add some constraints to these buttons. Down here, I'll say comma, then submit.topanchor.constraint equal to current answer.bottom anchor with no constant. Pin it right to the edge. Then submit.centerXanchor.constraint equal to view.centerXanchor with a constant minus 100. Put it to the left by 100 points so it does not overlap with the clear button. Comma. Submit.heightAnchor.constraint equal to constant 44. Be exactly 44 points high. Then comma, so we can do the clear button. Clear.centerXanchor.constraint equal to view.centerXanchor. Constant is 100. So positive 100. Move to the right of the center to keep it away from the submit button. Comma. Clear.centerYanchor.constraint equal to submit.centerYanchor. Keep these two things aligned with no constant. And then clear.heightAnchor.constraint equal to constant 44. Like that. So these are our two new buttons on the screen, both centered horizontally, one to the left and one to the right, and both fixed at a height of 44 points. Let's press Command R to build that and see how it looks. And there we go, submit and clear. Both on the same vertical line, but spaced apart horizontally to keep them separate. Now don't worry if you're feeling tired by now, it is hard work. Now don't get me wrong, building your UI programmatically has many advantages, but it's certainly verbose. Fortunately, we're near the end now, and all that remains is to add letter buttons at the bottom of the UI. We needed a lot of these things, 20 to be precise, and we'd make sure they're positioned neatly on the screen. With complicated layouts like this one, the smart thing to do is wrap our things in a container view. In our case, this means we're going to create one container view that will house all the buttons, then give that view constraints so it's positioned correctly on the screen. This is just going to be a plain UI view. It does nothing special other than host our buttons. So we'll add some more code below our previous view creation code. We'll say let buttons view equals a new UI view. Buttons view.tamic is false. And then immediately view.addSubView that buttons view. So just put it straight onto the screen. Now this thing is the last view in our user interface, excluding the buttons inside it, but they don't play a part in our auto layout constraints. So we need to give this thing more constraints so auto layout understands our user interface is complete. First, we'll give it a width and height of 750 by 320, so it precisely contains the buttons inside it. Second, we'll center it horizontally. Third, we'll set its top anchor to be the bottom of the submit button, plus 20 points add a little bit of spacing. And fourth, we'll pin it to the bottom of our layout margins, minus 20, so it doesn't quite run to the edge. So let's scroll down and add these final constraints to our array here. Buttons view dot width anchor dot constraint equal to constant 750, comma, buttons view dot height anchor dot constraint equal to constant 320, buttons view dot center x anchor dot constraint equal to, I'm going to choose view dot center x anchor with no constant, comma, buttons view dot top anchor dot constraint equal to submit dot bottom anchor constant 20 to make this thing 20 points below our submit button. And finally, as is the last view, we'll pin it to the bottom of our screen as well. So we'll say, comma, buttons view dot bottom anchor dot constraint equal to view dot layout margins guide dot bottom anchor constant minus 20. Now, just for testing again, I'll give this thing a green background color. I'll say buttons view dot background color equals dot green. So we have red, blue, and green being used now. We haven't added the buttons inside that view just yet, but please run the app now. I think you'll find the result very interesting. What you can see is our layouts changed dramatically. Everything that used to be pinned to the top of the view has now been pulled downwards. And this is not a mistake or an auto layout bug, but it's a natural result of all the rules we've laid down. We said this buttons view, this green view here, should be pinned to the bottom and be exactly 320 points high. We said the submit button should be above the buttons view, which it is. Then the current answer text field should be above the submit button, right here. Then the answers label should be above the current answer text field, which is here. And then the score label should be pinned to the top of our view, which is this thing here. In short, we have the buttons view pinned to the bottom and the score label pinned to the top, with all the other views in between. Before we added the final buttons view, auto layout had no special idea of how big any of the views should be. So it used something called the intrinsic content size, how big each view needs to be to show its content. This resulted in our views being neatly arranged at the top. But now we've got a complete vertical stack, pinned at the top and pinned at the bottom. So UIKit needs to fill the space in between by stretching one or more of the views. Every view in all our UIKit layouts has two important properties that tell UIKit how it can squash or stretch them in order to satisfy constraints. One is called content hugging priority. This determines how likely this view is to be made larger than its intrinsic content size. If this priority is high, it means auto layout prefers not to stretch it. If it's low, it'll be more likely to be stretched. Then there's content compression resistance priority, which determines how happy we are for this view to be made smaller than its intrinsic content size. Both of these values have a default, 250 for content hugging and 750 for content compression resistance. Remember, higher priorities mean auto layout works harder to satisfy them, so you can see that views are usually fairly happy to be stretched, but prefer not to be squashed. Because all views have the same priorities for these two values, auto layout's forced to pick one to stretch. In our case, that's the score at the top here. Now, all this matters because we're going to adjust the content hugging priority for our clues and answers label. More specifically, we're going to give them a priority of 1, so that when auto layout has to decide which view to stretch, they are first in line. So we're going to add 2 lines of code just so we create clues label and answers label. Up here. So we have clues label here. We're going to say clues label dot set content hugging priority with the UI layout priority of 1, the lowest possible, for its vertical setting. And I'll copy that to my pasteboard and put the same thing in for answers label. So make this thing have a layout priority of 1 for its content hugging. Make it stretch really easily. And if you run the app now, we should see a massive difference. Our 2 labels should now take up most of the space, and the rest of the UI will look normal. Boom, there we go. So scores no longer stretched, clues and answers are instead, which is exactly what we want. Now that our UI looks as it should, let's create the final piece of our layout, the letter buttons that sit inside Buttons View. We have 20 buttons to create across 4 rows and 5 columns, which is the perfect time to use nested loops. We'll create and configure each button, then position it inside the Buttons View as part of that loop. However, we're going to rely on a lovely feature of auto layout to make this whole process much easier. We're not going to set translate auto resizing mask into constraints to false for these buttons, which means we can give them a specific position and have UIKit figure out the constraints for us. So this actual button creation code isn't as hard as you might think. First, we'll set some constants to represent the width and height of our buttons for easier reference. Second, we'll loop through rows 0, 1, 2, and 3. Third, we'll loop through columns 0, 1, 2, 3, and 4. Fourth, we'll create a new button with a nice and large font. UI buttons have a title label property that we can reach into and modify. Fifth, we'll calculate the X position of our button as being our column number multiplied by the button width. Sixth, we'll calculate the Y position of the button as being our row number multiplied by the button height. Seventh, we'll add the button to our buttons view rather than the main view. As a bonus, we're going to add each button to our letter buttons array as we create them, so we can control them later on in the game. Now, calculating positions of views by hand isn't something we've done before, because we've been relying on auto layout for everything. However, it's no harder than sketching something out on graph paper. We create a rectangular frame that has X and Y coordinates plus width and height, then assign that to the frame property of our view. These rectangles have a special type called CGRect, because they come from core graphics. For example, we'll be calculating the X position for a button by multiplying our fixed button width of 150 points by its column position. So, for column 0, that will give an X coordinate of 150 times 0, which is 0. And for column 1, that will give an X coordinate of 150 times 1, which is 150. They'll line up neatly. So after our call to NSLayoutConstraint.activate, down here, we're going to say, first add some values for the width and height of each button to make our code easy to read. Let width equals 150, let height equals 80. And these 2 values are just values I've chosen to look good in this layout. You can, of course, experiment. Next, we'll create 20 buttons as a 4 by 5 grid. We'll say for row in 0 up to excluding 4, for column in 0 up to excluding 5. We'll start by creating a new button and give it a nice big font size. We'll say let letter button equals a UI button with the type dot system letter button dot title label question mark dot font equals a UI font system font of size 36. So a nice and big font. Temporarily, we'll give this thing some text so we can see it on screen. We'll say letter button dot set title www 3 nice wide letters for the state dot normal. We're going to calculate the frame of this button using its column and row. So we'll say let frame equals a CGRect where X is going to be the column times our button width. The Y is going to be our row times our button height. The width of the frame will be our button width. Height will be our button height. I'm going to assign that thing to our letter button by saying letter button dot frame equals frame. Finally, we'll add this thing to our buttons view by doing buttons view dot add subview letter button and add it to our letter buttons array so we can modify it later on. Letter buttons dot append letter button, like that. That's the last of our code complete. So go ahead and remove these 3 temporary background colors. Then press Command R to build and run the code and see how it all looks. Fantastic. There's our completed UI. We have score 0 in the top right corner, nice big clues label for all our clues, and on the right, answers label, a disabled text field with a placeholder text, tap letters to guess, 2 buttons below it, plus all our letter buttons neatly aligned in a grid below that. And this is all using auto layer anchors, which means we can go to something like portrait mode and it'll rotate and still look fantastic in both orientations. And of course, it'll work great in iPad Pro, iPad Mini, any kind of size, it will all look good. Now, while building this UI, it's possible you stopped more than once and thought to yourself, is this really worth it? It's certainly true that building this UI in a storyboard would have been easier, but learning to build UI in code is a really important skill.